Hi, I'm Patrick Reagan. Welcome to the Network Routing and Routers, Part 3, Routing Protocols, Part 2. In this video, we'll continue our discussions on routing protocols by focusing on BGP, EIGRP, and OSPF. As always, stick around for the practice question at the end to test your knowledge and help you prepare for the Network Plus exam. If you find this video helpful, don't forget to click the like button, and if you have not already, subscribe to the Pat Hedger Back channel for more tech training content and technical know-how. An autonomous system, or AS, is a large collection of IP networks and routers under the control of a single organization or administrative entity which operates a common routing policy. An AS is treated as a single unit when exchanging routing information with other networks, making it a crucial concept in routing protocols, especially on the internet. Each autonomous system is assigned a unique autonomous system number, or ASN, by a regional internet registry. The ASN is used to identify the AS when routing data between different autonomous systems. ASNs can be either 16-bit, numbered from 1 to 65,535, or 32-bit for larger networks. All the routers within AS follow the same internal routing policies, which means that the organization decides how data will be routed inside the AS and how it communicates with other autonomous systems. Interior Gateway Protocols, or IGPSs, are a category of routing protocol used to exchange routing information within a single autonomous system, typically within an enterprise or organization's internal network. These protocols control how routers with the AS communicate and share routing information. It's used to share routing information between routers within the same network and domain. Routers running IGPs automatically discovers the network topology and update their routing tables where changes occur. It focuses on quick convergence, efficiency, and minimized routing overhead inside the AS. Examples include OSPF, RIP, or EIGRP. Exterior Gateway Protocol, or EGP, refers to the category routing protocols that are used to exchange routing information between different autonomous systems. It is used for routing between different autonomous systems or between networks that belong to different organizations. Designed to handle routing across the broader internet, where multiple ASs must interconnect. The best known example is Border Gateway Protocol, which is the protocol used on the internet. The characteristics of EGP include: it operates between autonomous systems, typically on the internet. It handles the exchange of routing information between different organizations or ISPs, and it focuses on policy-based routing, scalability, and handling complex network topologies between ASs. Route summarization, also known as supernetting or route aggregation, is the method that reduces the number of routes a router advertises to its neighbors. Route summarization is most useful when there are many subnets to advertise. Route summarization can improve network stability and efficiency and help networks to scale to large sizes. Route summarization has many benefits, including: saves memory because the smaller routing tables reduce memory requirements, saves bandwidth because fewer routes to advertise means less bandwidth is used, saves CPU cycles because smaller router tables and fewer packets to process means fewer CPU cycles are used, and it enhances stability by preventing routing tables instability due to flapping networks. Open Shortest Path First, or OSPF, is a widely used link state routing protocol in computer networks that finds the best path for data packets based on the shortest path algorithm. It is an interior gateway protocol, or IGP, meaning it is used for routing within a single autonomous system, typically within large enterprise or organization networks. Unlike distance vector protocols like RIP, which use hop counts as their sole metric, OSPF calculates the shortest path using a metric called cost, which can be based on various factors such as bandwidth, delay, and other link parameters. OSPF is highly scalable, efficient, supports large and complex network, which supports multiple routers and balanced traffic load on multiple links. Using link state protocol, OSPF routers create a complete view or map of the network by exchanging information about the directly connected links or interfaces. Each router has a complete view of the network's topology, unlike distance vector protocols where routers only know about their neighbors. The shortest path first algorithm uses an algorithm to calculate the shortest path to each network destination. This calculation is based on the link state database that each router builds and maintains. OSPF supports a hierarchy network design with areas, allowing for more efficient routing and better scalability. Networks are divided into multiple areas with one central backbone area, or Area 0. Routers within the area maintain detailed knowledge of their own area, but have summarized information about other areas. OSPF is a classless routing protocol, meaning it supports variable length subnet masking, or VLSM, and classless interdomain routing, or CEDR. This allows for more efficient address allocation and network design. When the network topology changes, such as when the link goes down, OSPF routers quickly update their routing tables and converge, meaning they reach a consistent state across the network. OSPF has faster convergence times compared to older protocols like RIP. OSPF can perform equal cost load balancing for multiple paths with the same cost to the destination can be used to distribute traffic evenly. This improves efficiency and redundancy in the network. OSPF supports multiple forms of authentication, including simple passwords and cryptographic authentication, to ensure that only trusted routers exchange routing information. In OSPF, Area 0 is the backbone area that connects all other OSPF areas. It ensures that routing information can flow between different OSPF areas, making it a critical component of the OSPF network's hierarchy design. All non-backbone areas must either directly connect to Area 0 or use virtual links that maintain the integrity of the OSPF routing structure. Area Border Router, or ABR, connects different OSPF areas, typically the backbone area or Area 0 to other areas, facilitating inter-area routing. Autonomous System Boundary Routers, or ASBRs, connects an OSPF network to external networks or autonomous systems, redistributing external routes into OSPF and enabling communication between the OSPF network and other routing domains. Areas that are not connected directly to the backbone are connected via virtual links. Enhanced Interior Gateway Routing Protocol, or EIGRP, is an advanced distance vector routing protocol developed by Cisco Systems. It is often described as a hybrid protocol because it incorporates features from both distance vector and link state protocols, offering the best of both worlds. EIGRP is designed to improve on the limitations of older protocols like RIP, while being easier to manage and faster to converge than traditional distance vector protocols. Key features of EIGRP include classless routing, rapid convergence, efficient bandwidth usage, support for multiple network protocols, load balancing, metric calculations, and support scalability. An autonomous system in EIGRP is a collection of EIGRP routers that fall under a single administrative authority. Only EIGRP routers in the same autonomous system will exchange EIGRP information. You must configure the autonomous number of EIGRP instances running on each EIGRP router, and it must be the same in order for the routers to become neighbors. EIGRP uses hello packets to establish and maintain adjacent neighbor relationships with other EIGRP routers. It uses a reliable transport protocol, or RDP, to ensure that router updates are delivered correctly, including user acknowledgements and retransmissions when necessary. EIGRP provides unequal cost load balancing and rapid convergence. It uses the diffusing update algorithm, or DUAL, which identifies network paths and provides fast reconvergence using loop-free backup paths. When an EIGRP router calculates the route metric, it can use up to 5 variables. By default, only 2 are used: bandwidth and delay. The other 3 variables are reliability, load, and MTU. Each variable can influence the metric calculations based on wake values that are present in the hello packets. EIGRP uses the DUAL algorithm to calculate the successor, or best route, and feasible successor, backup route, for each destination in the topology table. EIGRP is largely a Cisco-specific protocol, which means it may not be suitable for multi-vendor environments. However, Cisco has made EIGRP partially open and other vendors can implement it, but it's still rare outside of Cisco networks. Compared to simpler protocols like RIP, EIGRP can be more complex to configure and troubleshoot, especially with advanced features like unequal cost load balancing. Border Gateway Protocol, or BGP, is the primary external gateway protocol used for exchanging routing information across the internet and between large independent networks known as autonomous systems. BGP is designed to manage how data is routed across the internet, ensuring that packets find the most efficient path between different autonomous systems, which can be thousands of miles apart and operated by different organizations. BGP is designed to scale to the size of the global internet, managing hundreds of thousands of routes. It can handle a large number of networks, routers, and paths that exist in modern internet infrastructure. One of the BGP's key strengths is that it allows for policy-based routing, which gives network administrators fine control of how traffic enters and leaves their autonomous systems. Administrators can prefer or restrict routes based on business agreements, performance requirements, or cost. BGP is a path vector protocol, which is a type of distance vector protocol that uses the AS path as one of the primary factors for making router decisions. The AS path is a list of AS numbers that the update has traversed. BGP routers adds its own AS number to the AS path sequence or attribute when it advertises the update to a neighbor and another AS. The AS path helps prevent routing loops and enables policy-based routing since it can see if the new route reaches the same AS number. If you tend to use BGP in the interdomain routing on the public internet, you need to register a BGP autonomous system number, especially if you multi-homed with multiple ISPs, running a network that requires independent routing policies, or operating as an ISP or large enterprise network with external routing needs. A BGP autonomous system number is a unique identifier that is assigned to an autonomous system, which represents a group of IP networks managed by a single organization or network operator that has a common routing policy. For most public BGP use cases, a registered public ASN is required to interact with other networks and route traffic effectively. Question: which of the following routing protocols is used to exchange route information between public autonomous systems? Answer: BGP. Question: which of the following uses the link state routing algorithm and operates within a single autonomous system? Answer: OSPF. Question: which of the following is an advanced distance vector routing protocol that automates routing tables and also uses some features of link state routing protocols? Answer: EIGRP. Question: which of the following routing protocols is generally used by major ISPs for handling large-scale internet traffic? Answer: BGP. Question: which of the following protocols widely used in large-scale enterprise networks to support complex networks with multiple routers and balance traffic load on multiple links? Answer: OSPF. Question: which of the following routing protocols use attributes to select the best path? Answer: BGP. Question: which of the following routing protocols use bandwidth and delay as the primary metrics to calculate the best path? Answer: EIGRP. Question: which of the following routing protocols is best suited for use on a perimeter route? Answer: BGP. Question: which of the following is a hybrid routing protocol? Answer: EIGRP. For more information, refer to these sites. In summary, an autonomous system, or AS, is a large collection of IP networks and routers under the control of a single organization or administrative entity which operates a common routing policy. Interior Gateway Protocols, or IGPs, are a category of routing protocols used to exchange routing information within a single autonomous system, typically within an enterprise or organization's internal network. Exterior Gateway Protocol, or EGP, refers to the category of routing protocols that are used to exchange routing information between different autonomous systems. Open Shortest Path First, or OSPF, is a widely used link state routing protocol in computer networks that finds the best path for data packets based on the shortest path algorithm. It is an interior gateway protocol, or IGP, meaning it is used for routing within a single autonomous system, typically within a large enterprise or organization network. Enhanced Interior Gateway Routing Protocol, or EIGRP, is an advanced disinfector routing protocol developed by Cisco Systems. It is often described as a hybrid protocol because it incorporates features from both disinfector and link state protocols, offering the best of both worlds. EIGRP provides unequal cost, load balancing, and rapid convergence, and by default, it only uses bandwidth and delay to calculate route metrics. Border Gateway Protocol, or BGP, is the primary external gateway protocol used for exchanging routing information across the internet and between large independent networks known as autonomous systems. Thank you for watching this video. The next video will be Network Routing and Routers, Part 4, Routing Redundancy and Miscellaneous Topics. If you like this video, click the like button, and if you have not already, subscribe to the Pat Hedgerback channel. Thank you.